Hi everyone, this is our look at chemical stability. There's three kinds of questions we can get about stability. We could get a question like this one, where we're asked to put molecules in order from least to most stable in a numeric response style problem. We could have this information in a multiple choice style question where we're asked which of the following is the most stable, which of the following is the least stable. The idea is that the table of molar enthalpies of formation in the data booklet can turn into a table about decomposition. We just have to change the sign. We have all these formation values, but decomposition is the opposite of formation. It's the reverse of formation. And we saw during our work on chemical additivity that when we take the reverse of a reaction, the sign of the delta H changes. So what we need to do is look up our chemicals in the data booklet and change the sign. And that will give us standard molar enthalpies of decomposition. And then the larger the value, the bigger the molar enthalpy of decomposition, the more stable the chemical is. The harder it is to break down, the more stable. Let's look at this example. Put these four chemicals in order from least to most stable. We have pentane, silver chloride, ethanol, and zinc oxide. What I need to do is look them up in the data booklet and change the sign. So I take my time. The chemicals are in alphabetical order here in the data booklet. It's not going to take me that long to find pentane, but I'm not using the number exactly as I see it. I need to change the sign. So I found it, and I changed the sign, and it becomes positive 173.5 kilojoules per mole. The next one is silver chloride. I take my time. Silver chloride. I look it up and change the sign. The data booklet says negative 127. I changed the sign. Ethanol. I find it and change the sign. Becomes positive 277.6. And finally, zinc oxide. Look it up. Don't forget to change the sign. Zinc oxide. These numbers now become the molar enthalpies of decomposition. Let's think about what that means. To get pentane to decompose, it has to absorb 173.5 kilojoules. It has to take in 173. Silver chloride will decompose when it takes in 127. Ethanol has to absorb 277.6 kilojoules of energy to break down, to decompose, and zinc oxide at positive 350. The larger the value, the more stable. So now I took my time, looked up those values, changed the sign, and I'm just putting them in numerical order. The smallest value will be the least stable, which is number 2. The silver chloride is the least stable. The next one is number 1. Pentane is the second least stable, and then ethanol, and then the most stable is the zinc oxide. So when I'm asked to put these in order from least to most stable, I looked up the values in the data booklet, changed the sign, and put them in numerical order, which is 2, 1, 3, 4. We could have been asked which of the following is the least stable. It was the smallest value for decomposition. It was silver chloride. Here the most stable is the largest number, zinc oxide, which must absorb about 350 kilojoules of energy to break down. We should definitely expect to encounter questions about stability. It really relies heavily on the data booklet. Don't forget to change the sign, and then we're just putting them in numerical order. And I hope that helps.